Welcome to C# for Crestron programming. In this video, we will begin to look at more dynamic storage mechanisms known as collections. The list type of collection provides greater built-in capabilities in dealing with variable data sets, including adding, removing, and sorting of items. We will be starting with a C# console app.NET framework project called Lists. The declaration of our list will occur at the global scope, so it is available in all methods in this class. Entering the keyword of list and examining the tooltip shows that we need to define a type for the list denoted as T within a greater than less than symbol set known as type container. Here we are declaring a list of type string, but we are not limited to the built-in types in C#, as we can create our own classes to use as types. Lists contain a zero-based index for their items and a property to provide a total number of items called count. However, if we attempt to access a list without instantiation, we get a null reference error posted. Within our main method, we will instantiate the list using the new keyword. Take note that the empty parentheses are required in the instantiation, as with the creation of any object of a class. We are calling the default constructor within that class. When initializing an array, it is important to include a length parameter for the array. Depending on the type of array, there will be a default value or a null value for each index in the array. With lists, there is no requirement to declare an item count, and although the list is not null, it can contain 0 items. If we attempt to access an array in the list that does not have an item defined, we get an argument out of range exception. Another defining contrast to arrays is when assigning items to our list. Since there is no index to assign against, we use the built-in method of add, with no index declared, to create the indexes. The list items are added in order. Here we have added 5 digital media cards to a list. Running our index-based writeLine statement will now provide a result. In order to access all of the items in our list, we can use any index-based loop. But most simply, a for each loop is used as we do not need to first check the size of the list. To fully utilize the power of lists will take some research. Entering the name of your list and hitting period to engage IntelliSense shows a long list of very helpful built-in methods to manipulate the contained dataset. In our program, we will demonstrate a few of these methods. Firstly, a basic sort method. Notice the order of the items in the list has been modified alphabetically compared to the original list. Secondly, we will use a remove method. This will remove an item from our list but does not leave a gap in our indexes. The method reassigns indexes in order to update the count of the list. Finally, if we wish to convert our list into an array of the same type, there is also a built-in method for this. The digital media cards are listed as pulled from the array in the for each loop. The online Microsoft.NET documentation provides details and examples of various methods built into the list type. You are encouraged to explore this documentation. You have now learned the basics of working with the type of collection known as lists. You have explored adding, removing, and sorting items in the list without regard to an index. Thank you for watching.